Hey, welcome back to our Breakout labs. In this lab, this will be Breakout 10, and in this lab we're going to create our bricks so that we can actually start breaking them. Alright, let's get started. I'm going to do it this time on Linux using Sea Lion. Be the same thing for you guys on Windows. If you created your last template off of Breakout 9, then you would just start up a new template. Otherwise, start a new template and copy your Breakout 9 code into it, which is what you'll see me do here in Sea Lion. So I'm going to start a new project. This will be Breakout 10. Keep changing the format on that. I think I'll do it without the underscore, Breakout 10. Alright, now it gives me this main file and I want to get rid of that. So I'm just going to say delete that. And yeah, I actually want to delete it. Yes, I want to delete it anyway. Okay, so I need to copy from Breakout 9 my header and CPP file. I'm going to go back up to repos into my Breakout 10 and copy those there. And then in the repos folder, I have my template for the CMake. So I'm going to open that with a text editor and copy this. This is what you get from the template in Visual Studio on Windows, is you don't have to do this step. So I'm going to come here and I just need to replace this last line. And then it'll ask me to reload those changes. And I should have my files in here now. So there's my Breakout H and CPP file, and here's the FGCU GL CPP file. And then if I expand the external libraries, I'll see here's the FGCU GL. That's where it sees the H, and then it should also be seeing the there's the GLFW code. All right, so let me close this. I'm going to just open up Breakout H and Breakout CPP, and I should be able to just build and run so I know everything came over good from Breakout 9. Let me run this. And everything's good. I can drive it around and it's colliding off my walls good. Make sure it collides off all four walls good. Okay, I'm going to hit X to stop. Alright, so we're ready to start Breakout 10. We want to start by defining some constants for our bricks. I'm going to be moving some things around a little bit in. Let me get rid of this window. Let me see if I can get this side by side. And then I'm going to hide the Explorer. There we go. Just a little bit, and I'm going to move this ball structure below this constant, and this will be the ball, and I'll do some kind of like divider here. Go out to say fit character 50 and do structures. Come up here and do this will be global constants and numerators. Actually, more like we'll just call them enums. That's actually what they are. And then I'll move these here then down into our global constants. All right, that's just going to give me a little bit more structure here as we start adding more stuff. We are going to add some definitions here for our bricks. And so we're going to start with the fact that we need to know how wide is a brick going to be. So let's do a brick width, and we'll say it's going to be 64 pixels. and then how high will be brick height, and that'll be 20 pixels. And so that's in our header file, we're adding those. All right, and now over in our main, we're going to add, we've got the walls, a ball, and now let's create a brick. So create a brick, and it's a block, and we'll call it brick, and then we're going to put it at, and remember, if we look at our block structure, we need an X, a Y, a width, and a height. So we are going to have window width. Let's put it in the center of the screen. So window width divided by 2.0, and then that'll put the bottom left corner of it right in the center. But let's center the brick by then moving the brick to the left from there. Half the width of a brick. So that would be minus and we just created those constants, brick width minus brick width divided by 2.0. All right, and then let's put the brick up in the center of the screen, so its Y position would be window height divided by 2.0 minus half of the brick's height. So brick height divided by 2.0. And then for a block structure, we need the width and the height. So that would just be our new constants, brick width and brick height. All right, and since this is going pretty far out, you can see they give us in C line, we're seeing a gutter here. That should be around column 80. Actually, it's column 110, so they're even going a lot further than that, which is good though. But anyway, we can just wrap this like that, or we can even wrap each one of them. All right, and there's our brick. Yeah, the blocks are being defined as ints because they're not going to be moving, so we don't need the fractions. So let me just get rid of those doubles there, or the floating point literals. Okay, so that should now suffice for that. All right, so now we have a brick created. Let's draw it on the screen. So we need to add it to our render method. So let's add a block here, and we'll call it brick. And then we're going to need to add that down below in the render method. So let's come down to our render, and we'll just, we declared it here in main. So we declared it right here in main. So that's our variable, so that's what we'll pass as an argument to it in the call, and then, oops, brick. And then down here in the render method, we can add it here. We added it right after ball, and now we have that brick. And now we can draw it here. We'll draw the ball and then we'll draw the brick. Okay, so it's just a quad, so we need an FGCU GL draw quad. All right, and then so for the X, the brick is a block structure, so we can do brick dot X position, and then for the Y, brick dot Y position, and then for the width, brick dot width, and for the height, brick dot height. All right, and notice we're gonna be using the default color white right now. Oops, what happened? Where did I jump to? I was in render. Here we go, here's render. All right, so let me put a semicolon at the end of that. All right, let's see if we can get a brick drawn on the screen. All right, and there's a brick. Now our ball is actually sitting right underneath it. And we notice that as of right now, our ball doesn't recognize the brick. It's not bouncing off of it. And that's okay, we're getting there. All right, so let's go ahead and move our ball so that it's not starting underneath our bricks. So I'm gonna come up here to the top where we define the ball, and we'll leave it centered widthwise on the screen, but instead of centering it its Y position, let's just fix its Y position to be, let's just say 20 pixels up from the bottom. All right, let's see where we're at. I'm gonna do a build and run. All right, now we've got our ball out of the way of our block. It's still not going to recognize the block for collision checking. We have quite a bit to add. All right, so let's add color to our bricks. So what we're going to do is we're going to do that in our block structure. And we are going to add to our block structure a color property, and we're going to make it an FGCU GL, right? And it'll be a color. And we'll call it color. And I want to see something because I didn't expect it to. Okay, so I think C-Line's being a little over helpful. It shouldn't have known what this was, but that's okay. Let's fix it. Before I finish this, let's go ahead and add, we should be including FGCUGL here. Now this is a system standard template library, so we want to do our local libraries after that. So I'm going to include, and we need to use the double quotes, and there's our FGCUGL header file. And this is our open GL library. All right, and if we start to reference FGCUGL stuff in one of our files, let me shrink this down. If we start to reference code from there, we should include it here. So we're back down here in our block structure, and we're doing a color. And okay, so what we're going to do is we're going to go ahead and set a default, because remember we created the walls right now, but we didn't, our walls, we didn't set a color for them. So we want to have a default color that the walls can pick up, since they're blocks also. So let's do our FGCUGL white, because our borders were white right now. All right, and that'll just be our default color. And now what we can do is over in our main program, let's see where we're creating our walls. Notice we create them, they are blocks, and we just fill their structure, but we don't fill a color property. So we won't need to worry about that new property right now since we've already set it to our color white. Okay, but now for our brick, let's go ahead and handle the color in our drawing method. So let's come down here to, I'm going to make this a little wider. Let's come down to our render method. There's process input, then update, then render. Okay, so here we're drawing that. So now what we can do is we can say brick dot color, and we can pass that to the color property. All right, and then we could do that as well for the walls. We can do, and this way if we decide to change our border colors, we now have that in place to do it. So this will be walls.top.color, and then I'm going to add that, and then just change it to bottom. And then down here, that'll be left. And then here would be right. All right. I hate that it's doing all this warning stuff, but that's okay. Fix that relative. Okay, so now we can draw a color for our brick. Let's come up and color our brick. Let's come back up to main where we declare our brick, and let's give it a color. Whoa. Let's come down here, we add a comma, and now we can define this new color, and let's do FGCU GL. Let's do yellow, because our bottom row bricks are going to be yellow. To start with, you guys can change the colors later. All right, so let's build and run. All right, now we've got a yellow brick. All right. So notice in doing these kinds of things, if we're making changes in the structures, we don't have to change anything in what we're passing to our functions, because our structures pass all of these properties as one block of memory. So if we add a new color property to a block, that becomes part of the structure of memory that we get when we declare a variable of that structure type. All right, even if we don't fill that in. For instance, we didn't provide a radius here, but here we had an integer radius, so that's another 4 bytes in the structure, but we already initialized it here to ball size. All right, so what is going to be next? Well, let's start working with an array of bricks. So instead of one brick, let's do an array of bricks. Let's say, for right now, let's have 3 bricks. All right, so we're going to do 3 of these. So what we're going to do is, this is the list initialization for one block. We need to do 3 of these. So I'm going to copy this one, and then I need to add a new list to represent the outermost array of bricks. So this is the initial list initialization for the array of 3 blocks, and then this will represent the first block, and I can do a comma, and then it wants to put it there for some reason, but I can try to reformat it. It'll fight you sometimes. Okay, so so that's in one brick, and then I want one more. copy from that comma so that I can paste it right here, and hopefully I have less I have to realign. All right, so that'll be my third brick. So now let's think about, right now we're starting at window width divided by 2 minus a brick's width divided by 2. Okay, well, let's just say we're going to start at the middle and go back a full brick to the left. So we just need to get rid of this. And so we're going to minus a brick. And then for the middle one, let's leave it centered in the screen. And then for the right one, let's go forward to the right a brick width. So we're going to do plus a brick width. And that should give us one brick to the left of center, one brick in the center, and one brick to the right of center. Well, let's see how we did. All right, let's build. Oh, I'm sorry. We have an array of bricks now. If we look at our render method, it was only set up to take in one brick as one block. So we need that to now be an array. And we don't have to do this, but it's good practice. I'm going to go ahead and put the size of the array that I'm going to send to it. All right, so we'll find out when we do a multi-dimensional, we don't have to provide the dimension for the first dimension, but we do for the other dimensions. And it gets kind of crazy remembering the rules. So the safest rule is always provide the dimensions. So our array is 3 blocks, so we're just going to tell the render, hey, we're going to send you an array of 3 blocks. So now we have to do that in the render method. So that's process input, update, and render. Okay, so now we told it we are going to be sending it 3 blocks. All right, and then here we want to draw, so we're going to change this to bricks. As a matter of fact, I meant to do that here. This is now going to be plural, bricks. And let me jump back up real quick so I don't forget and call that bricks. And then I don't remember if there's a shortcut to jump down to it. I know I can do a find usage. I was hoping there was a quick way to jump to its definition, but I don't see it. I can do a Control F and find it. That's where it's called, and that's where it's being used. So I just did a Control F to find it. All right, so in here now, this is now going to be bricks, but we're handling an array, so we probably could use a for loop. And so we'll just do something like integer I equals 0 because our arrays are 0 indexed, while our I is less than 3, which is the number of bricks in our array, and then we can do I plus plus to increment. And then I need my curly braces, and then I can move this into here. Right, and then this is now bricks, but this is a bricks array, so I need to give it the index I. And now I can do, now everywhere here where I see brick, I can just replace that. All right, and then the only change I want to make now, I've got that in renders, I want to come back up here to main. And you know what it is? I think there's a navigation pane that I don't have. Yeah, here it is. So now I can jump to main in the navigation pane. Okay, that'll work. And so here where I define this, I want to call it bricks. And then that means where I call render, down here, I need to pass it as bricks. All right, let's build. And let me shrink this down, and I'm going to run. Huh, so my sizing is off. We just need to go back a brick, plus we also need to go back half of a brick, since this one is going to be half a brick to the left And then that means we need to go plus a full brick, but then also minus a half of a brick to go back to the left. So let's not overthink it, and let's just see if this works and go with it, because we're going to make changes to that again. I'm just trying to get 3 bricks right next to each other in the middle. I did not run a compile, so okay, there we go. So now we have 3 bricks slammed right up next to each other. So one of the bricks is right here in the center, and it went to the center, and then we moved it back half a brick. The second one, we went to the center, we moved back a full brick, but then had to go another half a brick. The next one, we went to the center, and we went forward a full brick, but then we had to pull it back a half a brick. And that gave us 3 bricks. But what we see in the end is we have 3 bricks next to each other, and we can't tell where one brick starts and another brick ends. And that's what we're trying to get to, is we need a way to give these bricks a border. And so we're going to do that by eating into the brick to build a border. So let's see how we're going to do that. I'm going to do this by creating a new function, and it will be, if we go back up here to the top, we can see we've got our process input, our update, our render, and our collision checking. Well, this will be called by render, so I'm going to put it right under render. So right now these are our main 3 game loop functions, and then this is a helper function for update, and this will be a helper function for rendering. I'm just going to locate it right here under the render. So it will not return anything, and we're going to call it draw a bordered block. Okay, and then what we're going to do is pass it a block. Right, and it's just a block. In this case it'll be a brick, but this is a generic block that we want to have a border. And then we need to tell it what the color of the border is, so we'll pass it an FGCGL color. Sorry, remember enum data types are capitalized. We'll just call that, let's call it border color. And then we need a size, a border size. All right, and let's default that to 1, the size, and let's default the border color to FGCU-GL black, which is our background color. Now later on, if we have time, I'll add more things so that we can change the background color, and then you would be able to use like a define in your header file for background color, and that would be something you'd want to set here as your define. But for right now, we'll just go with, we know our background is black, and we want a 1 pixel border. All right, so I'm going to copy this, and I'm going to jump down to where render is, and notice the function show up twice here. We have the function declaration and then the function definition. All right, so here's our render method. Let me scroll down to the bottom of it, and then I'm going to put this right here. All right, and then I need to give it a body. All right, and then I want to go ahead and give it a comment block. All right, and I forgot that C line likes to help me with that. I'll just leave it, I don't mind that. And I'm going to say this is going to draw a block with a border. All right, and then parameters, it has the block, which is the block to draw, block position, size, and color. And then the border color, color of the border block, and border size, size of border in pixels. And let's just add pixels. Let's just add some. Draw a block with a border by drawing the block passed in on top of a background block sized up. Block passed in on top of a background block. Something like that. So that just gives an idea of what we're doing. Now remember, in the definition we have to remove the default values because they can only be in the declaration. Alright, so all we need to do is, first of all, let's come up here to render and copy this line where we draw the block now. Alright, so what I'm going to do is everywhere we're in this line, in C lion, replaces what? Find, replace, Control R. Okay, so in this line, how do I say in this selection? Okay, so in selection, which is the line I have selected, anywhere where I see bricks, I want to change that to block. So replace all. Okay, good. I'm going to close that find box. Okay, so in my draw border block, first thing I'm going to draw is the block here, but I'm going to draw it with the border color. Actually, wait, before I do that, let me make another copy of this. Okay, so draw background block, and that's going to have border color. Draw inner block, and that is going to have the block color, but it is going to be, it's going to start border size to the right, so plus border size, all right, and it needs to be 1 pixel up from the bottom, or border size up, and then we need to subtract 2 times the border size from the width because we have to handle the fact that it moved in from the left and we want it to move in from the right, so we need to do 2 times that. So minus 2 times the border size. And because of operator precedence, that multiplication will happen before it gets subtracted, so I don't need parentheses. And then same thing for the height. I need to subtract 2 times the border size. Right, and then of course we have the block color. And so what I'm going to do is, let's go here and hit return. And then I'm going to do it again, just so we can see it all on the screen. So, alright, so we draw the background block and then we draw the inner block. And so the background block is the full size of the block with the border color. The inner block is 1 pixel in from the left, 1 pixel into the right, 2 pixels less in the width, and 2 pixels less in the height for the block's color. So that's the block we're drawing on top. Right, so let's, now in our render method, we're going to want to call this. So here we want to call draw border block, and we're going to pass it bricks, oops, not blicks, bricks I, which is a block. And then we don't need to pass it a border color or a size because we defaulted those. So I can get rid of that now. Oh, I just need a semicolon. I was wondering why it was red down there. Okay, so now for each brick, For each block inside the bricks array, we will pass that block one at a time to draw a border block, which will actually draw two quads, one in the background and one over the top of it. All right, let's build that. Okay, and run. All right, and now we see what appears to be a border between. We're not seeing above, but when we get more bricks up here, we'll see a border all the way around the bricks. But we can see now, we can see where the bricks start and end. All right, and we can still drive our ball through it. Oops, what did I hit? All right. All right, now let's add some collision checking for our bricks. Let's see what we need to do. We are going to need to, let's look at our update function. Oops, structures, update. And we will need to pass our bricks to our update function. So let's go to our function prototype and let's pass our bricks. So after our ball, we pass in our bricks. And right now we still have this array of 3. And then if we jump down to our definition of update, we now need to add that here. And I'm going to say, I'm going to add to our comment here that bricks, the blocks, the rack of blocks. And I'm going to call it the rack of blocks because we're going to, at times, we're going to start referring to that entire set of rows and columns of blocks as the rack. And that's a term that's used in several games like this, like Space Invaders has a rack of aliens. This will have a rack of blocks. All right. And so that'll be our bricks. And then if we look down here where we're doing our collision checking and update, we check for collisions with the ball for walls. Now we can just check for the bricks. All right, so we're going to add in a little check here though, because we don't really need to start checking the ball for collisions until the ball has made it up to where the lowest brick is, right? And right now, we're going to end up changing this later, but for right now, let's do check for collision of ball with the bricks. Don't start checking until the ball has reached the lowest brick. All right, so we are going to build the rack from the bottom left over to the right, and then we'll go up a row and start building. So the lowest brick will always be the very first brick in our array. That being said, we can do an if test here and see if the ball's Y position, and we could even do plus the ball radius, so we're getting to the top of the ball. If it's greater than or equal to the bricks array I 0, the first brick in the bricks array, its Y position, which will be at the bottom of that brick. So if it's greater than or equal to that, then the ball has reached the rack of bricks, and we'll start to check for collisions. And the reason we're doing that is the whole time the ball is in the lower half of the screen, we can skip having to check the ball. because once we start to check if the balls hit any of the bricks, we have to check all the bricks, and pretty soon we're going to have a lot of them, and that'll be that'll be a little time intensive. So here we can do a quick check and just say, well, we don't need to check any of this. All right, so now that we're in here, we need to loop through that array again. So we'll just do int I equals 0. All of this is going to change soon when we get the full rack, but for right now we're just doing 3 bricks, I plus plus, and then here we just want to see, we want to add to collision. So remember we were doing an or, the vertical bar, or equal, and we can do a collision check, and it needs, we saw it needs the ball. Well, we have the ball, and it needs a block. Well, we have that in our bricks array at index I. And that's all we need to do for collision checking right now. All right, so let's build. So what we did, we added that in here, but remember to our update function, we had to add the bricks array to pass it. We do have one other thing to do. I'm sorry, you can actually see the error line right there. We added our comment for that parameter, and then at the very top, I'll just scroll up. At the very top, we added bricks to the update method, and then now we need to scroll down to where we call update. And here we need to pass the bricks array variable. Oh, look at that, it even told us that we're passing the ball by reference. That was nice. That's C-Line doing that. All right, so let's do a build. And then run. And now our ball should bounce off the bricks. Well, look at that. They're as solid can be. Let's see if we can bounce off the top of them. And then what happens? Can we bounce off the sides of them? Yep. Okay. Now we've got collision checking. All right, so let's see, we're going to need to make a couple small changes. We have our bricks, if we look over here, we said our bricks were 64 pixels wide by 20 pixels high. Where did my calculator go? We want to have 14 bricks across the screen. So if we do 64 pixels wide times 14, that's 896, all right? So if we look at it, our screen height our screen width right now is, oops, the scrolling is not working very well. Our screen width, our window width is 800, and our calculator said 896. Now we also have a border. Our wall size is 2, so our wall is taking up 2 pixels. So we need 2 pixels on the left and 2 pixels on the right, so we need 4 pixels right now. So we do plus 4, that would be 900. So we really need our window width to be 900 pixels. And we could actually build into this the formulas to calculate what the size of the block should be or what the size of the window, but it's really kind of a pain. So we're just hard code some of this. So we need 900 pixels. All right, so let's do this again for the height. We want 20 pixels as the height. Now this doesn't work out cleanly, but we want 20 pixels as the height, and we want 8 rows. So times 8, that's 160 pixels. And right now, we have 600 pixels. And if we were to divide that 160 by 600, we see that our rack takes up about just under 30% of the screen, and that's fine. That works out just fine for us, all right? But let's make it more of an even number. And actually, no, you know what? That's just fine. Let's just leave it there. I think that works out fine. We'll leave it at 600. What we could do is we could add 4 pixels right now so that we have a 600 height with 2 pixels at the bottom and 2 pixels at the top for the walls. Let's do that. So our window should now be 900 by 604. All right, and now what we're going to do is we are going to create the entire rack of bricks. But to do that, we need to add a couple more properties here. We need to know how many bricks do we have across and how many bricks do we have down. So we're going to add that. We'll add that right in here where we have the brick width and height. And we can just add those as constant int. And let's do bricks columns, and I know I'm doing it plural, it sounds kind of weird, but we'll say there's going to be 14 number of bricks across, and then constant int bricks rows, and that's going to be 8 number of bricks down. All right, so we're going to have 8 by 14 rack of bricks, or 8 times 14 we can see is our 8 times 14 is 112 bricks. All right, now we want to have a starting position for the rack of bricks. So really we want to know, like, basically where does the first brick start on the screen. So we're going to do that and it'll, by defining it here, it allows for us to refer to it in other places in our program. So we're going to do bricks start X, and that will be wall size. In other words, we just need to move over in the x-axis whatever the size of our border wall is, and that's where the first brick can start. And then for our bricks start Y, that here, let's just do the window, let's do half the window height minus the bottom wall and the top wall border, and that way the bottom brick is starting halfway up the screen. So let's do window height, right? And then we want to subtract from height the wall size, or we could do 2 times the wall size, right? Now we want to divide all of this by 2, so I'm going to do this and then do divide by 2. All right, and since we're doing int, I'm not going to do the 2.0 here for floating point. All right, so we're saying basically we want the bottom of the rack to start, of the first brick, to start halfway up the screen minus, well, we need the full height of the screen minus the 2 border walls, and then divide that by 2, and that's where the bottom of the Y should start. So we'll have half the screen open on the bottom, and the rack will start at the half starting upwards. All right, now we're going to change the way we're creating the bricks. So right now we have this mess that's starting to form inside of our main, which is making our main kind of ugly. So we want to kind of do something a little bit different. We're going to actually get rid of all of this. So I know it's going to look scary, but I'm going to delete it all. And I'm going to cut this. I'm going to leave that comment there because I'm going to come back there. All right, and right now we'll get a bunch of errors, but I'm going to create a function that's going to create the bricks. Now, in our logic structure here, this, remember, these represent our game loop processing. Game loop processing. All right, and then these are helper functions, and we're going to have creation. All right, and so we're going to create a new function here. And this is going to be called, it's not going to return anything, it's going to be called create bricks. All right, and it's not even going to take anything. Yeah, I'm sorry, yes it is. It's going to take our bricks array, but our bricks array is now going to become two-dimensional because we're going to have 8 rows of 14 blocks. All right, so we are going to have, if we look at our header file, we are going to have bricks rows. Let's make this simpler. Brick rows and brick columns. Brick rows of, and here's our next dimension, brick columns. All right, so we're going to pass that to this function. Now, we're obviously going to update this array inside of create bricks. And so you might think, well, I need to pass that by reference. And you would be right, except we find out in C++ that arrays are always passed by reference. So we don't have to put the ampersand there. In other words, we could update this bricks array in any function that we pass it to because the arrays are always passed by reference. And that's just a C++ism. But okay, so we have this function. I'm going to copy it, and then I'm going to come down. We did it before process input, so that's just under main. So here's process input, so I'm going to put that right here between the end of main and process input. All right, and I'm going to give us a body and put end create bricks. And then I need a comment block. All right, and this will be my create the rack of bricks. All right, and then parameters is going to be bricks, which is going to be the array of blocks, something like that. All right, and it's void, its return is void, returns void. Void. All right, so what are we going to do in here? Okay, well, for the main part, we need a loop so that we can create a block, and each block we can then stick into the array of bricks. So we can populate a block with its X and Y, width and height and color, and then put it into the array. So to get started, we're going to need to know, we're going to need a loop structure. So let's write that first. We're going to need, we'll do rows, and for each row we'll do columns. So we're going to have a row index variable starting at 0, and so that'll be at the bottom. Row 0 will be the bottom row, and since we have 8 rows, we'll go row 0 through row 7. So we'll do row equals 0, while row is less than our brick rows, we'll increment the row. All right, and then inside of that, and I'm going to put, end rows, or I'm not even going to put end, I'm just going to put rows. And then here I'm going to do for int column equals 0, and that'll be the left column, while column is less than brick, columns, which we know is 14, so that'd be 0 through 13, column, plus plus. And let's do columns. All right, so what we want to get to is inside here, we now want to define a block, and it's going to be relative to the current row and column that we're in. In other words, the X and Y coordinates. So we need to get those X and Y's prior to this. So I'm going to just put this here and we'll come back and fill it in. So we know the X and Y at the very beginning of the first block. And if we think about it, we will start at the bottom, the Y. We're going to do that one first, and you'll see why. We're going to create a Y variable, and we'll call that, that's going to be at brick start Y. That's where our bottom brick is going to start in its vertical axis. Okay. Now every row we need to start back over. X needs to start back over at the start, which is on the far left. So we'll do that inside the row. We'll do X is going to be the bricks start X. That way every row starts back at brick start X, but we only start at Y for the first row. And then every time we create a block, so this will be at X comma Y, and now we can fill in the rest. This can be our block width. Oh, what's wrong? Block width. Huh. Oh, brick width. Sorry. Brick width. Brick width. And then our brick height. All right, now we don't know the color yet. Okay, because we'll get to that in a second. But right now the default color would be what? In our header, the default color would be white. All right. So we're going to leave that there, and then for every brick in the row, we need to increment its column. So the first one will be at brick start X. The next one we just need to increment. So X plus equals brick width, and that'll move the next brick over one width, and then after the column is done, we need to move our row up one. So Y plus equals brick height. All right, so that's why we do our Y first outside the loops. So it's set once, and every row, when we finish a row, we increment the height of the next row. But for every row, we start the X out at the left, the brick start X, which would be just inside the border. And then for each column, we assign that brick and then add to the X for the next block in the for the next column. And we do that for 14 columns, and then we increment the height for the next row above, and we start the X back over. Okay, so after we've created the block, we can add that block to our bricks array at row and column. We can add this block. So now that we've set the properties of this block, we can say copy all these properties into the block memory structure at this address in the array. All right, now, I said the only other thing was the color. We want to adjust the color per row. So we are going to do a switch statement here. And we're going to switch on the row because we're going to know which color it should be based on the row. And we are going to have a case for row 0, which is the bottom row, and for row 1, which is the next row above it, we want the block, which is this block here, we want its color equal to FGCUGL yellow. All right, and then that will set those blocks in the array with a yellow color. So we need a break, and then case 2 and case 3. And I know Visual Studio will move the case all the way back over to the left under the curly brace, and that's fine, it doesn't matter. Block color is going to equal FGCUGL green. And you guys can change these colors later, but for right now, go with this color scheme because I'll refer to things over the next couple labs using the color names. Case 4 and case 5 block dot color is going to equal FGCUGL. What's the next one? Is orange. And then case 6, and we could just do default, but I like to spell it out. Case 7 is going to be block dot color. And I've got a couple of errors I got to go back and fix here. FGCUGL, and the top row is red. All right, so I need a dot here, block dot color, and here I need a break. All right. And then I don't need a break on this one, and I'm just going to put color. And this will be to assign color by row number. And that is not how you spell assign, I think. I'm not sure. There we go. Yeah, see, it wants me to have a default, but I didn't do one, and I'm not gonna. So I'm gonna leave that highlighted as a possible error. All right, sometimes I ignore the warnings. All right, I wanted to fully spell it out that line, row 6 and 7 are color red. Okay, so now create bricks will create our 8 by 14 rack of bricks where as we go through these nested loops, we will define a new block at the X and Y for width and height, and depending on the row, which color, and then copy that block into the array at that row and column. Increment the X coordinate, and then at the end of a column, we'll increment the Y and start all over again. All right, so all we need to do now is call create bricks. So I'm just going to copy that and come back up here to main where I left that here. And we're just going to pass it up. We still need to define our bricks array. And so that's going to be a block structure, and it's going to be bricks, and it was going to be brick rows and brick columns. Right, so that's our array variable, And we don't need to initialize it because we're going to just pass it in here. Right. And what we could have done is we could have declared this here and then declared another one of them here at the top and then have this return an array, but C++ doesn't like to do that. It would rather for arrays for you to pass them as a parameter and update them, since it passes them by reference anyway. It doesn't like you to have an array as a return type, because then it would have to do a really large memory copy possibly, and it doesn't like to do that. So that's why we're doing this as a procedure. Okay, so that got our bricks array created now. So create the rack of bricks. All right, so now the only difference here is that I'm going to copy this here, because when we look at our functions now, this only was taking a dimension 3 array, and now we need it to take a 2-dimensional array. And same thing for render. All right, so we've got some more updating to do. All right, so that's there. Now, if you look here where we were calling update, we're passing bricks, and render, we're passing bricks, and that's still the name of our variable here, bricks. And then when we get down here, there's our create bricks, and there's our process input, and here's our update. So now this needed to be our 2-dimensional bricks array. And then same thing with our render. And we have more things to fix, but let's go here to render. And this is going to be our 2-dimensional array now. All right, so we need a 2-dimensional array here. So we need, this will be, we can just change this one for row equals 0 while row is less than brick rows, and then row plus plus, and then we need an inner loop for int column equals 0 while column is less than brick columns, column plus plus, and then here, oh, I need a body, and then this will go in here, and this is going to now be row and column, because at every index of row column we have a block structure, and that's what our draw border block took. All right, now watch this. I'm going to copy this because I need to do another one of these just the same up here in update. So when we get up to update, right here I need to do something similar. So I am going to change that now to our collision check. I'm just going to cut that and put it down here and get rid of this for loop. And then in here, I am now going to do, I can just do this, cut that out and get rid of draw border block, and then I'm just replacing this last argument with that. Okay, so the only other thing is we need to change this. So instead of looking if the ball is below the lowest brick here, we can actually now use that define that we did here for the start y. In other words, if the ball plus the ball's y plus ball radius is greater than or equal to the starting y for the bricks, then we need to start doing collision checks because the ball has made it up halfway up the screen. All right, right, let's build. Can't tell if it's building or not. Oh, there we go, build finished, okay. And then run. All right, and there's our rack of bricks. And we bounce off the bottom bricks. All right, and so we can see that we have half the screen here that's empty, and then we start doing the rack of bricks, and then we have this space up here at the top. And we can see we have the first brick is here in the array. This is row 0, column 0, and if this is row 0, then we have column 0, 1, 2, 3 through 13, and then this is row 1. And then row 2 and 3, 4 and 5, 6 and 7. All right, so just to review what we did there, we changed our declaration up here in main for our bricks to be this two-dimensional array of rows and columns. And then we created this method create bricks that would set up all the bricks inside the array. If we go down to it is a we start the Y at our brick start Y, which is halfway up the screen, and for each row we start our X on the far left, and then for each column we declare a block and initialize it to that X and Y with width and height. We check which row it is in to set the color, and then we copy that block into our array of blocks at that current row column position, increment the X, come back around, do the next block in that row. When we're done with the columns, we increment the height for the next row and do it all again. All right, and then we made changes to our update to pass in the two-dimensional array of bricks, and also for our render. And then of course we need a nested set of for loops there to render the bordered blocks for each brick. And in the update we needed a nested set of loops to loop through them to check each brick against the ball for a collision. And so you notice once the ball has reached the lower brick, we have to check the whole rack. And the reason why is we're going to start breaking the brick. So let's make that happen now. To do that, we're going to break this check up into two things. First is we're going to do the collision check. So I'm going to copy this, and I'm going to create a variable here of our collision type. I think I spelled that wrong. Collision type, which is our enum that we have over here in our header file. So where's our enums up at the top? So our collision type. So we're going to create a variable here, and let's call this brick collision. All right, and we're going to set that equal to our call to collision check. All right. Now, if brick collision, because if we didn't have a collision, then we would pass back none, which would be 0. So if it's vertical or horizontal, this would be true, and we will come into this if loop, and then I'm going to cut that and put it inside here. And what we can do is we can now add, through an OR condition, that collision type that came back onto our current collision variable. Well, you remember it's an int because we're ORing these together if we have multiple collisions, and we're going to see multiple collisions in the rack of blocks happen. But if we OR these two together, this is 1 and this is 2. If we OR these two together, that's a 3. All right, so what we also want to do is if we had a collision, we want to blank out the brick at that spot in the array, at this spot in the array. So we want to say at this spot in the array, let's set that spot, that whole structure to 0. And that'll wipe out that brick. But we actually have to implement not drawing the brick, okay? And also, we don't want to do collision checking if a brick is empty. So we now want to do a check here and do if the brick at this spot, we want to make sure the brick at this spot has not been emptied. The easiest way to do that is to reference one of the properties of the block. Now remember, this is an array variable, but the array variable at this index and this index together is actually a block. So I can actually use this whole thing as if it was a block variable. And we can just say, well, let's just check if the y position is 0, because we should never have a y position that's 0. So if it's not 0, we can check for a collision because that brick has not been broken. Okay, so notice we're getting all these curly braces is why it gets crazy here, and we want to have comments to say if current block not broken has a y coordinate. All right, so then if we go down here, we can say not broken. And then if we look at this one, this was column, and this one was row, and this was ball reached the rack. All right, so you see how that really helps with all these curly braces we end up getting. So now for if the ball has reached the rack, the lowest brick, then for each row in each column, if the current block has not been broken, if it has a y coordinate, then we want to do a collision check. If there is a collision between the ball and that brick, we want to add that type of collision onto our collision variable, and then we want to zero out that brick. All right, so now we want to do, I'm going to actually copy this, just this right here, because we want to do the same thing in render. We don't want to draw those bricks if they've been broken. So down here in render, right here, we can do, let's do column and row, and then here I can put that and do, and then move this into there. All right, so now if current block has not been broken, has a y coordinate, then we'll draw it. Otherwise, we won't draw it. Okay, so let's build and run. Boom! We are breaking bricks. All right, let's try to speed this guy up. Let's get him a little bit more vertical. Okay. See if we can get him to do a left and a vertical and horizontal break. He's got to get into a hole up there to do it. We see him there, he broke 2 bricks. Almost. he's kind of breaking. Oh, that was almost. If he gets in one of these nooks, it'll do both a vertical and a horizontal. Oh, that was an almost. There we go. There you saw a vertical and a horizontal break at the same time. All right, so that's our breakout. We are only missing the paddle. And what we're going to do next is we're going to start moving some of these things to be objects instead of structures so that we can add methods to them. And then we'll add the paddle as that. Oh, look at that. That was cool. And then we will assign a value to each brick so that we can start collecting a score as we're breaking the bricks. And if we can get around to it, we'll add some trick shots on the paddle and called friction. And I don't know why that changed direction when it hit the bottom. That was weird. And then we'll add a scoreboard at the top, and we might even add a different speed per row once we get through the first row of yellows, where the ball will automatically speed up some in the X and Y axis as it hits a particular row for the first time. All right, so I hope you're enjoying this. I hope this is starting to look like a game, something fun to do, and come back for the next lab.